Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the classification of functions. Last time, we learned about power, modulus, signum, and floor functions. Today, we will learn about one-to-one and on-to functions. We will learn to identify them and use each function to solve problems. This should be an interesting lesson, students. Let us begin with an activity. Here are three relations. One of them is said to be a one-to-one function. Which relation is it? Why? Take a moment to answer this question.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Did you decide which relation is the one-to-one function? The answer is A. It is a one-to-one function because each element of the range is paired with a unique element of the domain. Relation B pairs both A and B with the integer 2. So it is not a one-to-one function. Relation C pairs every element of the domain with the integer 5. So it is certainly not a one-to-one function. A function of the form f is a function from A to B is said to be a one-to-one if and only if each element of the range is paired with exactly one element of the domain. If f of x1 equals f of x2, then x1 equals x2 for any x1 and x2 from the set of A. This is the same as saying that if x1 does not equal x2, then f of x1 cannot equal f of x2. If a function is depicted in a graph, there is another way of checking whether it is a one-to-one function. It is called the horizontal line test. For instance, using the horizontal line test, let us check whether the function given by f of x equals x over 2 is a one-to-one function. We must first graph the function. It gives us a line like this: y equals 1/2 when x equals 1, and y equals 1 when x equals 2, and so on. Then we simply draw a horizontal line across the graph. If the horizontal line crosses the line defined by f once at maximum, then f is a one-to-one function. Let us apply the horizontal line test in an activity, students. Here are 3 functions. Use the horizontal line test to determine which are one-to-one functions. Do your best, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. The graph for function A looks like this. Clearly, it passes the horizontal line test, and thus it is a one-to-one function. The graph for function B looks like this. It is possible for a horizontal line to intersect with f up to 3 times, so it is not a one-to-one function. The graph for function C looks like this. It also passes the horizontal line test, so it too is a one-to-one function. I am confident that you had no trouble applying the horizontal line test. Now, let us learn about onto functions, also called surjections. A function f from A to B is onto if and only if the range of f equals b. For example, observe this diagram. Does it depict a surjection? Take a moment to decide.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
What did you decide, students? The correct answer is that no, it does not depict a surjection. A surjection would look like this. Notice how the entire range of the function equals b. A function can be both a one-to-one and an onto function. If this is the case, it is known as a one-to-one correspondence or a bijection. The function f from A to B given by f of x equals 3x minus 2 is a one-to-one correspondence. Let us prove this together. Let x1, x2 be of the set of real numbers such that f of x1 equals f of x2. Then 3x1 minus 2 equals 3x2 minus 2. 3x1 minus 2 plus 2 equals 3x2 minus 2 plus 2. Therefore, 3x1 equals 3x2, so x1 equals x2. So we have proved that f is one-to-one. Now, let y be a real number. Is there a real number x such that y equals f of x? If there is, we can find it by solving y equals f of x equals 3x minus 2. This can be rearranged into y plus 2 equals 3x. Then we can solve for x. So x equals y plus 2 over 3. So for any real number y, take x equals y plus 2 over 3 is a real number. Then f of x equals f of y plus 2 over 3. We can write this as 3 times y plus 2 over 3 minus 2. The product of this equation is y. So f is onto. Since f is one-to-one and it is also onto, f is a one-to-one correspondence. Today, we have learned about one-to-one, onto, and one-to-one correspondences. These terms are also known as injections, surjections, and bijections. Teacher, after the class, please hold a discussion about the uses for these different classifications. That is all for this lesson. Until next time, thank you, teacher. Thank you, students.